Okay, so welcome everyone to Denby Dale Amateur Radio Club and our regular weekly meeting on Zoom. Great to see club members, and for Mike's benefit, G4WNC, who's our speaker tonight, because we've been running our Zoom meetings for over a year now, on virtually every single week, with speakers from all over the world. One of the fantastic benefits, and we made a deliberate decision in Denby Dale, was that we threw our meetings open to anyone who wants to join in and to come along. Don't have to pay anything, you don't have to be a member, just come and join our meeting if you find the topic interesting. And we seem to have recruited all these new members. So we've actually doubled our club membership here in Denby Dale in the last 12 months, which is brilliant. But on the way, we've recruited members who have also now joined the club from one or two other parts of the UK and other countries as well. So on the call tonight, we've got various club members now located in North America, in the States. We've got Adrian and Mike from Germany, Jeff from Belgium. We've got Tom and Sue in South Africa. So they are now members of our club as well, Denby Dale. They're going to struggle a bit to meet us down the pie hall, but it's fantastic to see them in our Zoom meetings. So I'm going to afterwards, obviously, just before we close later on tonight, when Mike's finished, just run through some of the upcoming meetings we've got. We've got some more speakers in the diary, which is great news. I'd like to welcome Mike G4WNC. For those of you that are RADCOM members, you will have seen a couple of months ago in RADCOM a feature that Mike wrote on the ZUMspot, and setting up and using one of the commercial ways of enabling those of us that have got digital radios to link our radio to the computer network through the internet, and through that access the various digital networks that exist. So it was a fascinating article, and I'm really pleased we've got Mike here tonight. And I did say to Mike when he joined me about 20 minutes or so ago, I'm going to listen very intently, because one of my things I've never got round to doing is ever making any QSO on any of the audio digital networks, even though I've got both a System Fusion radio and a D-Star radio. So I'm going to give it a go, I'm quite sure, sometime. So I'm going to listen to Mike very, very intently. So Mike, I'm going to hand the microphone over to you, and you can introduce yourself and go ahead. And when you've finished, obviously we'll throw it open to questions and comments from the floor. So Mike.
Thank you very much. Excellent. Great to be with you tonight. It's lovely to see that you've got such a wide audience. That's really good, and I commend you for sharing like that. It's a really good way to go, I think, and it really accentuates what we're about as an amateur radio community of sharing. So the talk I'm giving tonight is a new talk. I've never given it to anyone else, so I'm trying it out on you. Now, I ought to give a few disclaimers to start off with. I don't consider myself an expert on digital voice, or the ZUMspot for that matter. I first got introduced to it when I started doing the review. So it was a whole process, was a learning experience. I'd done some work with digital voice before, but not with the ZUMspot. So the idea of this talk is really to give you an introduction to digital voice and using the ZUMspot. And I'm going to cover a few of the basics, I hope you don't mind, just to get everyone up to speed on what happens with digital voice and why it's like it is. Because if you've not touched it before, it can be quite a confusing subject with a lot of conflicting names and abbreviations. So let's look at what I'm going to cover. This is the plan for this talk. So I'll talk about how you digitize speech, the fact that we've got 3 standards now, a bit about digital networks, an introduction to the ZUMspot, a bit about using the ZUMspot, and then I'm open to questions. So I suspect this will take, I haven't done it before, so I don't know. So I suspect about 40 minutes, something like that. So let's get started. So the first thing we need to think about with digital speech is how to get digital speech from ordinary analog speech that we all know and love. So the normal way to do that is with a device called an analog to digital converter. And these work by taking rapid voltage readings of the signal and converting those readings to binary numbers, which is then the data that we send. So we get a stream of bits come out of an analog to digital converter, which is a digital representation of the analog signal or the voice that we put into it, which is all fairly straightforward. The problem, though, is that if we just do the straightforward conversion, it uses way more bandwidth than we've got. So that starts to make things a little more complex. So if we look at it pictorially, so if this is a speech waveform, as you can see, it's freehand drawing I did. When we digitize it, this is basically what we do. Take a whole series of measurements at regular intervals, and the result is a string of ones and O's that represent that signal. So that's fair enough. That is the standard way of digitizing. That's what we use in SDRs and everywhere where we digitize something. And I suspect you're familiar with this. So what we need to look at now is, so why does that use too much bandwidth? So if we look at an example, so a typical speech band would be a range of frequencies from 0 to 3 kilohertz. Often perhaps we use a little bit less than that, but for the sake of easy numbers, let's call it 0 to 3 kilohertz. Now, according to the Nyquist theorem and information technology theory, we must take readings at least twice as fast as the highest frequency that we want to capture. So for 0 to 3 kilohertz of audio bandwidth, we must take readings at least 6,000 readings per second. Okay, which is fairly straightforward. Now, in order to get a reasonable representation, our digital voltmeter, which works in steps rather than continuous because it's a digital meter, we need to use 256 steps, which relates to an 8-bit number. So each measurement we take provides an 8-bit number. So I suspect you can start to see the problem occurring. So the data rate that's coming out of the analog to digital converter will be our 6,000 samples per second multiplied by the number of bits for each sample, which means we've got 48,000 bits per second. So that's quite a fast data rate. And when you look at what's available in the FM band, for example, then there's no way you're going to get 48 kilobits of data into 12.5 kilohertz of RF bandwidth. So that's the initial problem when it comes to digital voice on the UHF and VHF bands. So how can we overcome that? Because what we really need to do, we don't need to aim for 12.5 kilohertz of bandwidth. Really, for the future, we need to be aiming for 6.5 kilowatts of bandwidth. So that's really tall order given that high data rate. So how can we do it? The only way really to do it is to throw away more audio information. Because as you can imagine, in the voice, there's a huge amount of information. For a start, there's background noise, which is unwanted information. But there's also a range of timbres around the main voice which add to the character of the voice, but not necessarily add to the message in the voice. So some of those things can be discarded. And maybe we can take advantage of some digital processing techniques to further reduce the bandwidth. So one way of doing it, which is a common way of handling it, is to divide the speech band signal into narrow frequency bands. And then in each frequency band, we analyze it to see if it contains speech components. Okay, if it does, we'll keep it, but anything that's not speech, we discard, therefore reducing the amount of information in that particular band. And then all the resulting data that we want, we then use digital compression techniques to make it smaller. So I'll show you the process here. Here's a picture of how it works. So we take the band 0 to 3 kilohertz, and we look at a narrow band and we ask, is it speech or not? If it's not speech, it goes in the bin. If it is speech, it goes through and gets squished. And we do it for each of those bands, those narrow bands, all the way through the audio range. And at the end of it, all those compressed bits of data are assembled together to make a data stream that we can send to the output. So that's what our what's known as a vocoder, a voice encoder, has got to do in order to make a much smaller bandwidth signal for use in the digital network. And those speech components are then sent over the digital link. And at the other end, the speech is reconstructed by the decoder. And that's why you'll notice that all the digital radios, the voices have a robotic quality to them. It's difficult to get past that because the speech is reassembled from components rather than being an accurate representation of the original signal that went in. Because it's looking to extract all the parts that actually count in terms of helping the communication and only include them. So you inevitably end up with this robotic quality, which when you first come across it, I think it puts a lot of people off because it sounds quite odd. And it's a bit like listening to SSB for the first time. People who've never heard SSB find it very difficult to understand initially. And it's much the same with digital voice, that it can appear to be difficult to understand at first, but once your ear gets tuned into it, it does get easier. One of the side effects of this compression process is that it actually throws away lots of noise. So the noise reduction on a digital voice network is actually very, very good, because all that noise gets thrown away. So what's the practical solution? So remembering that at the time a lot of this was developed, this is the whole of the commercial world of digital radio that's trying to find a solution, not just amateur radio. And so there were academic and commercial teams involved in devising a good system for encoding voice that could become some sort of standard for the future. All the results were compared and tested internationally, and the winner was selected as what's known as AMBE, which is active multiband exciter. So that uses the technique I've just described, as the name implies. It breaks the audio signal down into multiple bands and then processes it and compresses it. And it was developed by MIT in Massachusetts, but is now become Digital Voice Systems Incorporated, and we all pay a license fee to them for the benefit of using these encoders and decoders. So one of the reasons perhaps for the price of some of these things is because there's a license fee durable to Digital Voice Systems Inc. Now DMR, which is the commercial one and also used in amateur radio, D-Star and Yaesu Fusion all use the AMBE vocoders. So it's a common system throughout all the amateur radio digital systems. And it is really very good. No one's come up with anything that's better than it yet, which is good news. And what's quite remarkable about it, remembering we started off with 48 kilobits for the speech. This reduces the speech data rate down to just 2.45 kilobits per second, which is quite a remarkable reduction in data rate. And that then becomes relatively easy to fit into a speech channel. So, so voice and a data channel can easily fit in this target 6.25 kilohertz RF bandwidth that we're looking at. So it's a very well designed system, and it does do the job extremely well and makes it practical to do digital voice and data in a very narrow RF channel. And of course, the data side of it, whilst it may not be as important to us from a commercial viewpoint, it's really important because people are using their mobile radios like delivery vans, etc. Having a data channel you can pass information back and forth on is really helpful. So problem is, although DMR there, as I've just described, and the AMBE is a nice idea as a standard, from an amateur radio viewpoint, we've ended up with 3 standards, which is a bit inconvenient. So we've got D-Star, which was developed by the Japan Amateur Radio League. ICOM is the primary supplier of D-Star equipment, as you probably know. The other system, which is the later one on the market, is Yaesu System Fusion, which is a proprietary Yaesu system designed specifically for amateur radio. So, and because of that, it's got a few benefits over the others. And finally is DMR, digital mobile radio, which is the most common commercial radio standard, certainly in Europe and many parts of the world. It's an international standard, and as I say, it's been adopted for commercial digital radio. So those are the 3 systems we've got, and they're likely to stay for a number of reasons. So for D-Star, it's been around the longest. A lot of people have invested in D-Star. Also, as we've seen, it comes in a lot of your rigs anyway, so people are going to keep using it. The Yaesu system is likely to survive as well because Yaesu have been very generous in funding repeaters for a lot of people. And so it's taken on for that. And DMR will remain because of the strong commercial market. So from an amateur radio point of view, DMR might be a favorite because there's a good chance we can get hold of surplus commercial gear and use it for amateur radio. And so you can get into DMR a lot cheaper. And in fact, some of the DMR that's angled towards radio amateurs, you know, you can buy quite a decent radio for sort of around £100, which is quite attractive to people. So those are the 3 standards. So let's just look at them in a table form. So looking along the top row, you can see that the vocoder, which is the bit that compresses all the audio, D-Star uses AMBE Plus, which is an early version. DMR uses AMBE Plus 2, and so does System Fusion. So they both use the same encoder. All 3 use a slightly different modulation system. Okay. And in terms of being able to get more than one conversation down the same channel, D-Star and Fusion rely on you tuning to a different frequency. So frequency division multiplex basically just means that it's on a different channel. Whereas DMR uses time division, which enables it to send 2 conversations over the same channel. And I'll show you how that works in a moment. So in terms of the transmission rate, D-Star has got a digital rate per each channel of 4.8 kilobits. DMR does 2 channels of 4.8 kilobits, whereas Fusion does 9.6 kilobits. In terms of the bandwidth that they occupy, D-Star uses just a 6.25 kilohertz channel. DMR uses 12.5, but that's for 2 channels. So it's effectively 6.25. And Fusion uses 12.5. Now the subjective one, I've put speech quality in here, and I've given a rating against it. This will be very subjective. I'm sure some people will argue with me that D-Star is better than DMR. From a technical viewpoint, DMR is better than D-Star because it uses the later encoder, which produces a better result. And Fusion is better because it uses a higher data rate. Again, now the sound quality is also greatly affected by how you use your rig. So if you overmodulate at all or overload, it completely makes a mess of the digital system. So to get good quality voice, you need to get used to your rig, to know how far away from the rig you need to talk to get good quality. And you can only really check that by testing with others. And as you can see, I've just put an index below that of what the different modulation types are. They're all very similar in their own way. So that's a comparison of the systems. So now I'll just show you how the DMR time division multiplex works. It's quite a neat system. So the digital voice is sent into small packets. So rather than it being a continuous stream of data, it's little packets of data. And the packets are sent to one of the two available time slots. So you may have heard people on repeaters talking about whether you select time slot 1 or time slot 2. That's effectively the two digital channels that are available on a DMR link. And the time slots are interleaved and processed as independent channels. The timing is critical, obviously, because if you've got two rigs trying to transmit to one transmitter on the same frequency and you want to interleave the packets, then the synchronization needs to be very good to do that. So before you can transmit on a DMR repeater or to another DMR station, your receiver has to sync with the repeater, which it does in the background. It's not a big deal. So here's a little illustration of how this works. So you've got two rigs here, both trying to use a DMR channel, each one on a different time slot. And the time slots come together like that. So it's literally take it in turns, one after another. Now they don't fit quite as tightly together as it looks there. There's a certain amount of guard space either side of the slot to allow it to fit in, but that's how they work. And then, of course, at the repeater, they can be extracted out again into the separate links. So that's what time division multiplex is. Basically divides the channel into time slots and you put your conversation in the appropriate time slot. But all this happens in the background. The technology does this for you. You just have to decide whether you're on TS1 or TS2. So what's the digital potential then? We've now got to a point in this description where we've got digital radios, we've got a very efficient data stream running. What does it give us that we didn't have before? So we've got a choice of 3 similar digital voice systems, but it opens up a whole load of new possibilities. For a start, because the signal is digitized, then it's quite easy to pass a data signal over the internet. The digital voice packets also include some error correction code, so they can be regenerated and improved if necessary. And because of the internet, we could link repeaters together to improve the coverage. So we could, for example, link some local repeaters together to increase the coverage. And there's also the option for online transcoding or mode conversion. So maybe we could use computers connected on the internet so that we could talk using D-Star and talk to someone using DMR. All these things are possible once we've got the internet connection. So let's look at the networking opportunities so you can see what it starts to look like. So it's a simple start. So maybe we've got a group of repeaters that we can link together. So we can have a single mode geographical network. So all these these 4 local repeaters are all connected together, so you could talk to anyone who comes up on one of those repeaters, which is great for increasing the coverage, and is a simple use of the internet and digital voice. But we could do more than that. So another option could be where we've got a whole load of repeaters that could have various people connected to them. And on the right here, are you seeing that panel with moving across the screen with my face on? Let me just minimize that. Don't want to interrupt the display. So we could have a whole load of repeaters that are able to connect to an internet connected computer running appropriate software. And so we could send our data voice signal to that and have it bounce the signal out to all the other repeaters. Now, this device that does this internet connected computer that does this, is commonly called a reflector. I think D-Star call them reflectors. In DMR, they're sometimes called reflectors, but more often called talk groups. And in WiresX on Yaesu Fusion, they're called rooms, but they're essentially the same thing in that it enables you to connect lots of different things together. And the possibilities are endless. They're endless to the fact where you can have worldwide networks, and there are worldwide talk groups. You can have a UK-wide talk group. You could have a special interest talk group. And so all you're doing is routing to a computer on the internet, which links out to the appropriate channels on a whole load of other repeaters. So it's a really powerful concept that completely opens up the world to DMR. And what it enables is you can be there with your handheld, linking to your local repeater and talking to someone on the other side of the world, just by choosing the appropriate reflector or talk group. So let's look at them a little bit more. So they're a very powerful addition to the network, as I think you can probably see. Global QSOs via the internet. And you can link different systems together. So you can link D-Star to DMR to System Fusion. You can have geographical talk groups or reflectors, special interest talk groups or reflectors. Basically, you can always make a QSO once you get on the digital network. The scope is so wide that you won't ever struggle to make a QSO. So they look really useful. Now, the problem is, as I think we mentioned with Adrian at the beginning, he's got D-Star on his rig, but he's not sure he can get into the local repeater. And that's a common problem, that people can't reach the local repeater. So you have to somehow be near a repeater in order to use the network. That's, as it turns out, is an unnecessary limitation. So what we can do is create our own private repeater. And it's called a hotspot or a personal hotspot, various names that it gets called. So these are low power units, typically only about 10 milliwatts of power. They use your home internet to reach the repeater networks. And they're available to handle all the digital voice modes. Most of them are multi-mode in that you can set it up to handle any one of the digital voice modes. Many of them can also translate between some digital voice modes, but to be honest, you're better off using the online transcoding systems. So here's an illustration of what a hotspot looks like. So you start off with your UHF handheld, and you have your hotspot. and that connects to the internet and then off to the rest of the world, wherever you like. So it's really simple. You can wander around your house, down the garden, all over the place with your handheld. And your hotspot is like your base station that you communicate with, and it allows you to go into all the different talk groups, etc. So if we just look at the ZUMspot and what it is and what's inside. So there are basically two components in the ZUMspot. There's a Raspberry Pi running the Pi-Star software, and it's that links to the internet. And below it, or actually on top of it, as it happens, you've got a radio board, which is running the multi-bold digital voice modem firmware. And that's what your radio talks to. And a ZUMspot is as simple as that. It sounds simple, but there's lots of technology going on under there. But they work extremely well. So the ZUMspot only deals with digital information. There's no analog to digital conversion done. All that is done in the rig. So the AMBI encoder or vocoder chip is inside your rig, and it's not used in the ZUMspot. And it reacts to information supplied by the local radio. So when you want to talk to a particular reflector or talk group, you actually select it on your radio. And when you key up and talk to your ZUMspot, it picks up the talk group that you want and makes the connection for you. So you don't have to keep setting up the ZUMspot. It does whatever your rig does. So you could go on what's called a tactical channel. You could go on a reflector, whatever you like, whatever's stored in your rig. When you key up, your ZUMspot will just repeat that request and off you'll go and connect up. The 10 milliwatts of RF is plenty to cover most domestic uses. When I had the ZUMspot here, the furthest I could get in my modest area was about 35 meters away from it, and it all worked perfectly outside, upstairs, out of the front of the house, all over. So 10 milliwatts seems to be plenty. Make sure you keep your rig on low power though, because you really don't need anything at the lowest setting that it will go. Although the ZUMspot will do some limited mode conversion, I suggest you use the online multi-mode reflectors or talk groups to talk across groups, because they're much better. So here's a look at the ZUMspot itself. So the little box on the left is the ZUMspot. That's the Anytone little DMR rig, which was quite a cheap one. I think that was about 80 quid, 90 quid, something like that. The ZUMspot is a very neat little device. It's got this little rubber duck antenna, which is its 70SEMS antenna. And you can see the little black wire going away is just a standard micro USB cable, which is there to provide the link to the computer. That's a close-up, and what you see on the top is the LAN address of the ZUMspot, along with what it's currently doing. So at that time, I was talking to this guy, Janez. I was on slot 2, linking to talk group 91. So it's got a little status thing on there. Now, this is the screen that you get at if you access the ZUMspot with your browser from a computer. You go into the Pi-Star software, and the Pi-Star software is what sits on top and runs everything with a friendly interface, if you like. I know it looks quite complicated, but once you get used to it, it's very helpful. So this screen, the gateway activity, shows all the things that are passing through historically. So it's just a timeline of activity. And you can see on the left-hand side the networks that it's set up for, call signs, etc., and all the details about how it's linked up. So that's what the Pi-Star software looks like, which you can use that to configure the ZUMspot and also to monitor activity, etc. So let's just look at a few operating techniques that I've learned from doing this. So I recommend using it in single mode to match whatever rig you've got. So if you've got a DMR rig, set the ZUMspot up to operate DMR only. Likewise for D-Star, Fusion, etc. It's the simplest way to get going, and it's also the most effective way to use it, I think. Keep your rig on the lowest power setting at all times. Disconnect when you're not in use. Don't leave it running. The Pi-Star software is actual full-blown repeater software, but don't be tempted to start opening up the repeater options because you'll get in a pickle if you do. Keep the node type set to private, and what that means is that only your call sign, if you're using D-Star or Yaesu, or DMR ID can use the ZUMspot. So it's just a level of security to stop other people using your ZUMspot. In terms of operating technique, it's courtesy to leave a gap between each over to allow someone to break in, someone else to get on the channel, etc. The nature of the system, particularly if you're going through reflectors, etc., is that there's a bit of a time lag between things happening. And if you start doing overs quickly, then no one else has got a chance to come in and say anything. So always leave a gap between transmissions. And also when you're making your transmission, after you've keyed up, just pause for about a second or so before you start speaking, again, to allow for time lags in the system for everything to link up. Otherwise, you will find that the very first part of your conversation gets cut off. It's just simple operating tips that might help you with using ZUMspot and digital voice in general, really. Now, if you want some help with setting up hotspots, DMR, or Pi-Star, then this website is absolutely brilliant. This guy's done a whole load of notes about using them. They're very detailed notes, and they're up-to-date notes about how to get going. And it's very, very helpful to get your hotspot set up first time and to work out how to use your DMR or Pi-Star rig. At the moment, I don't think he's got anything on there on System Fusion. But that's probably the best site I've found for help, for talking you through things to get you started. So that's the gist of this talk. I'm sure there'll be some questions to get you through to just getting going with the ZUMspot and understanding a bit about digital voice. I put my mini advert up there because I supply, one of my main interests is the Raspberry Pi. I spend a lot of time with the Raspberry Pi. I've got a book out on it, and I sell SD cards pre-formatted it. So if anyone's interested in any of that, that's the place to go. So if I stop screen sharing, then maybe we can take some questions.
Brilliant, lovely. Thank you very much, Mike. That was really interesting, and I certainly followed it, and it was good just to get an understanding. As you said, looking at it, it does seem slightly complicated that we've got these three different networks. But anyway, can we see who wants to go first with a question to Mike? So who's, yes, I've got John. Need to unmute, John, you're still on mute.
All right, that better?
That's it.
Yeah, sounds good.
A couple of points. First, thank you for a very interesting talk. Very succinct to the point. I not relevant to the main thought, but you mentioned it's necessary to speak at the right distance from the microphone.
Yeah.
A competent VOGAD system is not exactly new technology. I was using one of these over 40 years ago, which meant you could talk over your shoulder like that or bellow into the microphone and get the same deviation. Surely they should perhaps concentrate a little bit more on the operational aspects of their radio before getting into digital complexities. Point number one.
Yep.
Point number two, this is great, all these features, but if you're an occasional user, what chance have you got?
Yep.
If you
Okay.
haven't get the book of words out and you didn't touch it for 2 months, you've got no chance. My opinion.
Yeah. Well, you can simplify it actually to stop it being so complicated. If I do the first point about overload, I think it's more a question of microphone dynamics as much as anything, of not speaking too closely and all the rest of it. I suspect
what
most
I'm trying to make the point is that you can do this electronically.
Yeah, I know.
Built a system over 40 years ago that would cope with a whisper or a shout.
Yeah.
In the same deviation.
Yeah, all I'm reflecting is that's the practical situation at the moment.
Yeah.
That people who've got bad voice quality on DMR, it's sometimes because they're misusing it as opposed to the rig itself, if you see what I mean. But it's just something to be wary of, and if you're aware of it, then it's quite easy to do a test with a colleague who's got a rig and just to make sure the way you're using the rig is actually working as you expect. In terms of complexity, yeah, it is. It does tend to be overly complex, and it's especially so if you have what's called one of the code plugs downloaded onto your handheld. So when you look at buying handhelds from any of the dealers, most of them will say it's got the full code plug installed. And a lot of people don't know what a code plug is. It's a rather odd term. It's basically a frequency list and channel list. So it's like all the memories for your radio. It's just become called a code plug from the days when digital radio started. Whilst it's all well and good having every channel on your rig, it does make it very confusing. And what I recommend doing, and what I did for the review, was I dumped the code plug and actually learnt how to program just the channels I wanted into the rig. So I had one zone with the channels I wanted, which was only 3 or 4 channels that I wanted to use. And so then it makes it quite easy to come back to at a later stage and just to pick it up and use those few. If you've got the full code plug in, you've got hundreds of stations on there, and you could quite readily get very confused, I'm sure.
I assume most of those would be out of range too.
Yeah, that's right. Yeah, or they're also ones that you would get to via talk groups, if you like. But it's, yeah, it does overcomplicate it, I think. That's my personal view. I favour just putting in the rig what you actually need. And that would certainly cope with the situation where you want to come back to it and use it occasionally.
Yeah, my point is that there's so many different operating modes. That's just too much to remember. I can not touch my gear for a year, come back, pick up the mic, select the channel and talk.
Yes.
Do that with this, because there's so much people who appreciate what it can do, which is very powerful, but the big but.
But the other part that I'm slightly uneasy with is that I think all the technology in this is great, and I really enjoy technology and working on things like this. But if you think of amateur radio as an emergency service, now fortunately we don't have occasions in the UK where we need emergency radio networks, but if we all end up on DMR and D-Star and everything else, relying totally on the internet, then amateur radio will be totally useless in a disaster, because you can bet your boots the internet will sink.
Well, that's right. Nothing reliant on external services is valid for an emergency situation.
Yeah, that's right. So, yeah, it's all, I mean, for a lot of people. I
used to be involved with this professionally at one time.
All right. Yeah. I mean, for a lot of people, DMR is an absolute godsend. If you're incapacitated in some way, if you're living on your own and you want to talk to people, one of the great things about DMR is you can always get a QSO. So it can be great support for people who want to talk to other radio amateurs at any time of the day or night. It can really work for that, and you can set it up quite simply for that. You don't have to have all the different talk groups and everything on there. You can restrict that down to a few where you'll get what you need. So it can be really, really good. It can be very, very confusing.
Yeah, I follow in the last school, I'm afraid.
That's okay.
Thank you, John. Thank you, John.
Repeaters, since they went away from 750 tone access.
All right. Yeah.
Because the kit won't cope.
Yeah.
Right, Gerald, I've got you waving your hand.
Thank you. Great talk there, Mike. It was really interesting. Just a couple of points. First of all, is it possible with DMR to work simplex? There are some simplex digital channels on both 2 and 70.
Yes.
Because you only say it seemed to be working via repeater, and I just assumed that. Is there any way that Echolink, which is also a digital system, can be linked into the existing digital ones?
It probably can be, but I don't know whether it might even have been done, but I haven't looked at that. So I'm afraid that's a bit of a don't know from me. So I can't really help you with that.
And also, just a quick one, if I may, aren't there some other amateur-derived methods as well as the AMBE one? I read an article by a guy in Australia who was saying that they were developing a separate system of their own, and I wondered if that is common with the ZUMspot linking into that system as well.
Yeah, there are other systems being developed because of what people quite like. In amateur radio, we like to be open source, don't we? And of course, the AMBE is not open source; it's licensed, and we all have to pay a license fee when we use their decoders. So yeah, there are a lot of people working on similar systems. It's I guess it's about how do you get that propagated throughout the world? You know, because people have got their ICOM and their Yaesu rigs, and they're probably going to stick with them. So at this point, with 3 systems established, it's quite difficult to introduce a new system, I think.
Yeah.
Yeah.
Gerald, the one that you're thinking of in Australia is called Codec 2.
Yeah, that's right.
Yeah.
I couldn't remember it on top of my head.
Yeah.
Thank you.
I've used it on 10 meters, and it is actually just as good as DMR or Fusion in terms of voice quality, but it's obviously not well adopted.
Yeah. It's the same with all standards, isn't it? Adoption is the rule. You know, if you can get it adopted, it can be rubbish, but
yeah.
you can still get away with it. We've seen it many times with video standards and all sorts in the past. Yeah, so it's very difficult. Now it's established now. You've got the 3 big manufacturers with their versions. Really difficult to get in.
Okay, thank you, Gerald, and thanks for that interjection there, Russell.
Sorry.
Who else has got a question or comment to make to Mike? Yes, Andrew.
Yeah, good evening, Mike. Thanks for the talk.
Hi, Andrew.
I do reiterate some of the things you've said, actually. As you say, there does seem to be a delay when you key up on DMR.
Yes.
It does take us a few seconds to. I use it through the local repeater, and it does seem to take a few seconds to key.
Yeah.
And then also when you drop the key off, you do have to wait to reply to somebody because it takes a few seconds to clear on the repeater from them talking to you, doesn't it?
It does, yeah. Yeah, there's all sorts of things going on in the background during those periods, but it's not as you might expect it of a sharp on and off. So you once you're aware of that, it's okay. But if you go on there expecting it to be like an FM call, you'll end up losing the beginning of each transmission.
Yeah, that's right. And the other thing you said as well about I got a radio with a code plugin, and I eventually ended up ditching it and finding out, watching YouTube videos how to do my own, and just put in the local repeaters that I'm in range of. I found it much easier doing it that way. as you say.
Yeah, you learn how to use the rig as well, which is helpful, as opposed to just taking something that someone else has concocted.
Yeah,
yeah. I think the retailers push the code plugs as being a wonderful benefit, but I just think they confuse people a lot of the time.
That's true, because I had code plugs for repeaters, you know, down in the south of England, which were no good to me anyway, unless I travelled. So
no, that's right.
They were no good. And just one last thing I'd like to ask, I'm not sure if you'll know though, is when you change your call sign, I've just recently gone from an M7 to a 2E0. Do you have to have a new ID? Do you have to change your ID?
Oh, no, I don't know. No, I don't. I'm sorry. No.
I think I'll probably just have to go and set up a new ID for
it probably
my
will
new
be.
call sign.
Yeah, it probably will be.
Yeah.
Yeah.
Okay, thanks for that.
It's okay.
Okay, thank you, Andrew. I've got Richard, 2E0 JFH.
Yeah, hi, thank you for a very interesting talk on a subject that I didn't know a huge amount about. One of the things I sort of picked up on that you mentioned in passing was about this has a potential to be a threat to amateur radio as we all know it, in that we then become dependent on the internet, as opposed to being dependent on the airwaves. I mean, do you envisage this as being a way of actually forcing people out of certain bands potentially to reallocate those to other uses?
I don't know whether it would come to that, but it does. I mean, you can actually go a step further than I've described tonight, because you can buy an AM/BE decoder in a USB stick that you can plug in your computer, and you ditch the radio. And all you use is your headset on your computer. And you can get in and do all the same things you can do on your rig with DMR, but from your computer. So you don't even need a radio, which is, you know, you're then starting to get in, well, really, you're talking about an internet chat room, aren't you, rather than amateur radio?
Yeah.
So I'd be surprised if it had that effect, because I think the interest in it is, I don't think the interest is that great. I mean, there's a lot of hello, goodbye conversations going on DMR when I was listening around. And by hello, goodbye, I mean, you know, the sort of thing where you give them your name, you give them your QTH, you tell them what wonderful rig you've got, and then you hand it back to them for their final, you know.
Yeah. And the other thing that I thought about when we were discussing, I mean, for myself, I work with computers all day, so the last thing I really want to do on an evening or when I've got some spare time is actually work some more on the computer. So I feel myself shying away from this area of it totally. But one of the things you mentioned about the Australian Codec 2 developers, does this have the potential to be as disruptive to this setup that there currently is as Linux was to the Windows brigade in the late 90s, early 2000s?
No, I can't see these independent decoders being disruptive, because I don't think, I struggle to see how they'll get taken up in any sort of scale, because the only way they'll get taken up is if a major manufacturer takes it on board as the way forward. And I can't see Yaesu or ICOM doing that at the moment.
Yeah,
and
not really.
No, and of course DMR is a big international standard anyway, which is undergoing continuous development.
Yeah.
And unless there was a significant advantage with the new vocoder, I wouldn't imagine that they'd go seeking anywhere else particularly.
That's great. Thank you very much indeed for a very interesting talk.
That's okay, my pleasure.
Brilliant. Thank you, Richard. Anyone else? Yeah, Jeff.
Hello, good evening, everyone. Thank you very much, Mike, for a very interesting talk. I do like to read your column in Practical Wireless every month, so really enjoy
well
that. I have some more practical questions. I mean, in frequency modulation on 2 meters, you can use that to send slow scan TV or RTTY. Can you do that with DMR or D-Star or so on?
No. The problem with the digital voice systems is that they're designed solely for digital voice. So if you tried to put a constant tone through, as you would from any of these sort of digital modes, it would recognize it as noise and throw it in the bin. So it wouldn't get through the processor. So,
okay, the RTTY would be first converted into digital signals, actually. Or
yeah,
that would be the solution. Because it's analog. It's an analog signal.
It is, yeah. So I mean, to be honest, a RTTY signal starts as a digital signal. We turn it to analog to make it tones for an SSB rig. If you put those tones into a vocoder, it would almost certainly see them as not speech, in which case they would probably be thrown away, and so they wouldn't pass through.
Okay.
And if they did get through, they would probably be quite distorted from their original state. So I can't, well, the only way you could do that sort of stuff is on the DMR channels. There is a digital path, a data path. So you can send messages through the data path. And actually the data capacity of the data link is far more than a RTTY link. So if you wanted to send a message, you could do it that way, but you couldn't really send RTTY over it.
Okay. I think on D-Star you have this picture exchange possibility, which is actually doing that.
Yes, it's using the digital link. Yeah.
And just another question, maybe a little bit off topic, but anyway, it's in the framework of your column. Digital modes like FT8 or whatever, could you do that on satellites, on a full duplex satellite transceiver? Because you need to send up a signal and to get down a signal at the same time. How is your FT8 program or FLDG? How could you do that? Because it should go through your USB cable from the 9700, for example. How would you split up that to get a signal to send and a signal to receive at the same time, and on another VFO, actually? That's a different one.
So you're talking about doing FT8
on a satellite
via satellite. Yeah.
An SSB, for example, on an SSB satellite.
Yeah. You could do that. So FT8 starts as audio tones. So and if you're going via the satellite, you're sending audio tones. I haven't tried it. One of the issues may be associated with timing, but I don't think that would be too bad. But it should be possible. I'm trying to think of a reason why you couldn't do it, and I can't think of one at the moment, other than timing, because...
You're alive.
Hello. Oh, yeah. Oh, right.
I know
you're not even going to qualify it.
I know that there are some Spanish amateurs who are using FT4 on SSB satellites.
Right. Yeah.
But I tried to contact them. They don't understand very well English, and my Spanish is very limited, so I didn't get a good answer. But they do it anyway. They do it, and they have a net on Monday evenings on certain satellites.
Yeah, that should be doable because it's not undergoing the same voice processing as DMR or any of those things. So yeah, that should be doable.
Maybe a topic for your column.
Yeah. Yes. Yeah, I'll look at that actually, because I've got to put my satellite thing back together again. I've got it in bits at the moment, so once I put it back together again, I will have a crack at that.
Okay, thank you, Mike.
That's okay, my pleasure.
Thank you.
Yeah, thank you, Jeff, and 10 out of 10 for sneaking in that additional question. Jeff, M0AUG.
Thanks, Mark, for a very interesting talk there. It's explained a lot of things to the people who are newer to the digital modes.
Oh, thank you. Yeah, that's what I was hoping for.
Yeah. I've been using D-Star for probably 12, 13 years, and more latterly Fusion as well. Where we find it particularly useful, I'm still a member of the Oldham Radio Club, even though I'm a member of this club now, but I live distance from the Oldham Club, and it wouldn't be possible to have any direct contact with them. So we have a digital net on a Sunday morning on our own reflector, which is a multi-mode reflector, and we can bring in members from, like me, up on the northwest coast in Blackpool, which is nowhere near to Oldham, one of our other former chairman who lives down in Bristol, etc. So we can keep these people together by using the digital network, and that's good for us.
Yeah, that is, isn't it? Yeah, that's really good. Yeah, it's a good use of it. Definitely. Yeah, there's certainly a lot of benefits you can have from it. Yeah, well done.
And the advantage of that for us is that we've obviously got a mix, like most clubs have, of people who are on D-Star, people who are on Fusion, and a few people on DMR. And because this is a multi-mode reflector, then we can take all comers on the net on a Sunday morning. And that's really good, really, so people don't have to go and buy additional kit to be part of the group, if you will. So thanks again, Mike.
What's the name of the reflector? What's the name of the reflector?
XLX305 Alpha.
Say that again. X3.
I'll send you an email, Jeff.
Okay, good. Yeah, fine.
Yeah, the multi-mode reflectors are a real boon. They've transformed it really, because in the earlier days, well, we'll have to make a decision between DMR, D-Star, and maybe Fusion. It's really difficult choice because you don't know what repeaters are going to pop up where. You're totally dependent on whatever repeater happens to be near you. So the multi-mode repeaters, reflectors, are a big boom and make a difference to it. It means you can have any rig and still communicate.
The point that you made actually there, Mike, that don't try and transcode through your hotspot is a good one, because we've had people who've sort of been trying to join the nets in the past who've been actually doing the transcoding there, and of course the audio's gone to pot and all this, that and the other. So we've said to people, keep to the node that you're on and let the reflector do the job for you.
Yes, it would be better if they excluded that as an option, because it's not the way to go. Yeah.
Correct. Yeah. Thanks again for the talk, Mike.
That's okay. Thank you.
Well, thank you, Jeff. I've got Ken, VZV.
Yeah.
Okay.
Good evening, Mike. Thank you for the talk there about data stuff. Right. My question, it's like three questions in one here. It looks like we were licensed round about the same time, looking at our call signs.
Right here.
And what I want to know is what's taking you down the path of this data modes, and what is your background? Have you got a background in computing? Because obviously computers has played a big part of it. And what is it that you strive to gain what I'm trying to say is, as a pure RF man, I try to build aerials to get the greatest distance around the globe. How do you do, or what do you do in the same sort of angle of what I'm coming from? You're putting a kit together, or you're using these digital modes, and it's done by computer. So where are you actually aiming or trying to, what are you trying to achieve?
Cool, that's putting me on the spot, isn't it? Okay. So my background is I've been playing radios pretty much all my life. I built my first radio when I was 10. My dad used to repair radios, so I grew up with radios. We used to go window shopping on a Sunday to radio component shops with my dad. stood out there in the rain looking at white spot transistors and wondering whether we could afford some more and stuff like that. So I've been doing it quite a while. My career was in BT, so I've done lots of different things in the engineering side of BT, from putting poles in the ground through to running outside broadcasts and all manner of things. So I had great background there. My amateur radio life started off as GHHA, which was quite a long time ago. And I was quickly disillusioned because at that time, everyone was buying damn Japanese radios and I wanted to build stuff. And I was cursing that, to be honest, because I was very much into home construction. And I went off it for a while. And then I came back later on and got my G4. And my interest has always been in receiver technology, particularly. But I've always been very closely involved in data as well. So back in the 80s, I was experimenting with data systems over amateur radio, where we used to annoy all the local amateurs by running full duplex with a 300 baud BT modem going out on 2 meters and back on 77s, and connecting a TRS-80 to a Ohio superboard computer. So those sorts of things have always interested me. So I've always been around computers and that side of things. At the moment, most of my time is around the Raspberry Pi and software-defined radio. And I particularly enjoy all the latest advances in software-defined radio. So I haven't got a distance goal, so I'm not trying to get anywhere in particular. I just enjoy playing with technology. And in a lot of cases, once I've got it to do what I want it to do, I usually put it aside and go do something else. So as proof of that, I no longer own a ZUMspot.
Where do you think you will be then in 5 years' time with this?
Oh, I'll have a little matchbox size SDR transceiver that will work the world, I expect.
Right. And do you not do any RF radio then?
Yeah, I do RF radio as well because it's necessary as part of the hobby. So yeah, I do the RF side and I do follow it through. But once I've been down a particular avenue, I then go and experiment with a different avenue.
Right, I'm with you. Okay then, Mike. Lovely. Thanks very much.
That's okay.
Thank you.
Thank you, Ken. Right. Anyway, yeah, Terry, VFC.
Yes, hello, good evening all, and Mike, thank you very much. It's interesting that only a couple of 3 days ago I came across the Freestar something or another, where I could hear contributions from all of the DMR and D-Star and FM even. It all came out on the one channel. I couldn't quite get my head around that because many contributors were a particular signal strength, but some were decidedly different signal strengths. So I don't quite understand what that was about yet, but I will. You mentioned earlier on about when you listened, you were hearing a lot of, we used to call them rubber stamp QSOs, of course. Hello, my name is, I'm running a 1, 2, 3, 4, and over to you. You are 5 and 9. 5 and 9 on D. I don't understand that bit either.
No.
So I've had a DMR for 2 or 3 years now. I've never really enthused about it because I never hear anybody talking about anything in particular apart from those sorts of QSOs. And indeed, with the requirement to leave a pause of a second or two between overs, I don't see really how a meaningful conversation can happen and be developed into something that's interesting. Am I missing something, or am I listening at the wrong time to the wrong place?
There are some places where you will find some interesting QSOs going along. personally, I wasn't terribly impressed. And it's not for me. It's not. I enjoyed learning about it. I enjoyed learning how to do it. I enjoyed understanding the technology of how it worked. But this goes down in my book of been there, done that, and now I'll do something else. Thank you. Sorry to disappoint, but
no, that's how I feel entirely. But I do wonder as to what the future of digital, digital QSOs are. FT8 is wonderful for filling up the logbook and getting lots of printable QSL cards.
Yeah.
But not a lot else, I think.
No. I mean, the thing about FT8 and FT4 is they're specifically designed for you not to have a conversation.
Yeah, it saves the bother, doesn't it?
Yeah, they're designed specifically for weak signal, minimum contact, and they're really useful for that. So, if you're really trying to work a difficult link, they're a fantastic tool. But when you're working massive signals all day long on FT8, it doesn't really mean terribly much.
No. It would be nice to have these weak signal capable modes if you could then impose upon the signal some meaningful message.
Yes. Yeah, people have tried. I mean, there's the what's it called now? The alternative to FT8. I can't think of the name now. A guy developed
GS8 call. GS8
yeah,
call.
that's the one. Yeah.
Which is it?
JS8 call.
Oh yes.
What he did, he adapted the code so that instead of sending the fixed exchange, you could actually send a message. The problem is it's painfully slow, of course.
But if that's the only link you've got, it could be ever so useful.
Yeah. Oh, yeah, that's right. In emergency situation, it could be a fantastic tool. Yeah.
Anyway, thanks. I don't want to pour cold water on it. And
no.
And you've done the legwork, which has saved me a bit too. Thank you.
That's okay.
GS8 call. Yeah, GS8 call is very good because you can send APRS messages. You can send SMS messages to a telephone. It's a brilliant thing if you are in an emergency situation. Like if you are in the middle of nowhere, it could save your life actually.
Yeah, it is very. It's unfortunate it's been looked down upon.
Yeah.
Because I don't think Joe ever supported it, Joe Taylor, and I think they were a bit peeved when he started messing with it, because to them it was designed purely as a weak signal system, and it was never designed to take messages, but actually to adapt it so it could be used for messages is quite a good idea.
I had a rack shoe with a guy in Hong Kong for 3/4 of an hour with my 10 watts into a mobile whip here on 20 meters. So you can do a rack shoe with signals at min 20 dB, minus 20 dB. That's unbelievable.
Yeah, it is good, isn't it? Yeah, the technology behind it is really good. I mean, you look at the people that designed it, and there are some top brains in information technology design there. So it's not surprising it's good, but it just seems a bit silly to just have it left for kicking up points in a competition with not much effort.
Yeah, you're right.
I'll get shot after this. I can see that.
Not one bit. Point, if I may. My understanding of the licensing is that encryption is not permitted. And yes, here we've got a manufacturer's proprietary encryption. Surely there's a dichotomy there.
There isn't there, really? Yeah.
Isn't the difference this is encoding, not encryption?
Yeah.
Same difference. It's a proprietary system, the details of which are not released.
Yeah, that's right. Yeah, it is effectively. Because if you've got an ordinary FM rig and you've got a D-Star rig running, you'll hear a nasty buzzing noise, but you won't be able to interpret it or find out who it is. There's no plain text in it, so that is true. Yeah.
I might offer that the means to decode is freely available, free not being in monetary terms, but it's easily available. It's
Yes,
ubiquitous.
it is.
It's
Yeah.
not a secret. It's not a
Yes.
secret.
No, it's not. No.
Yeah, Jeff again, M0AUG.
Yes, Jeff.
Thanks. Just to cover off Terry's point a little bit, I think part of the problems with DMR in particular is that you connect to one of these UK-wide talk groups, and you're literally talking all over the country and even beyond, and that's what a lot of people don't want to do. The same applies with Fusion. If you go onto things like America Link or D-Star, if you go onto the Mega Repeater D-Star Reflector 001, that's not all that the digital modes are all about. Part of it is being able to communicate with people on a one-to-one or a small net or whatever without being overloaded with 100 other people listening into your conversation. And I think that needs to be taken on board.
Yeah, it does. Yeah, you need to be careful when you do these UK-wide or global talk groups that you're actually broadcasting over a hell of an area.
I think sometimes people who are new to the digital modes forget this, and they go on thinking that's the answer, and then because they're overwhelmed by what they hear, they don't push the PTT. So consequently, they never go with the digital mode.
Yeah.
Stick the radio back in the drawer and say, "Stuff it! I'm not playing that anymore."
Yeah, well, that's one of the problems of having the full code plug installed, is that you can just flick around to these groups that you don't necessarily want to be on.
Yeah.
Okay, anyone else got a question for Mike? I think can't see anyone waving. Who was that?
A very quick one.
Yes, go on.
I can buy perfectly functional Chinese FM rig for about 60 quid, 25 watts, 60, 70 quid. What do I have to pay for a digital rig?
If you use DMR, you can get one for about 90 quid.
That's come down a lot.
Yeah. Yeah, if you buy Yasa or Icom stuff, it's significantly more than that. But if you buy one of an Anytone DMR rig, I think the one that I reviewed with the ZUMspot was about 90 quid.
Yeah, because I've been looking at this area recently to try and get something for 4 meters, which made me look at other things. And I thought, dear me, a little bit. But okay, thank you.
That's okay.
Okay, thank you, John. If we've got no one else, can we first of all show our appreciation normal way to Mike for a really interesting talk tonight?
Thank you.
Thank you, Mike. Very good.
Yeah, brilliant, Mike. That was a really good talk, and I think as a number of our regular club members are also contributors to Practical Wireless, Mike. So as well as readers of it, and of course Radcom. So delighted to have your talk tonight, and I think you did a really good job there of just trying to make the whole subject understandable to us. So I'd like to thank you very much indeed, Mike, for
my pleasure. Yeah,
popping along tonight. It was great.
Thank you very much. Okay, I'll leave you to discuss all my mess ups.
You don't have any, don't worry.
Yeah, 73 to you, Mike. Cheers.
Bye.
Thanks, Mike, and best wishes to Elaine.